Okay, so I'm just going to talk about coupled model control systems, and more particularly the coupled model control systems that we've developed at the Met Office with regard to our particular coupled systems, and highlight the old cliche that problems may be the same as opportunities, or perhaps opportunities just create problems. And this is work sort of that's arisen from discussion with the people listed there and many more besides. So I'm just going to say how we got to where we are with the systems we currently use, the difficulties with those, which in my view sort of comes down to responsibilities, who's responsible for which bit of which system, and what the opportunities are for the way ahead and for the changes, or at least my thoughts on the way ahead. So the evolution to our current system really, I guess, began back in the early 1990s, where we just had what you see before you, which was a series of subcomponents, all combined within a single executable. And there wasn't really, there was a user interface for that, but it wasn't anything that you would claim was a graphical user interface. It was quite an old-fashioned thing. I mean, hence the date, you know, the 1990s. But it was a coupled model of sorts. Our first MPMD system really came along in the early to mid 2000s. Again, this is where we introduced the use of Oasis 3. We had therefore a separate Ocean CIS and Ocean BGC component, and a separate atmosphere, which is the Met Office Unified Model atmosphere. That also contained land and chemistry, etc. And at that stage, as you see on the left-hand side there, in the pink box, we had a GUI, which was quite a nice GUI, but it was based on TCL-TK, Tickle-TK. And on the right-hand side, we had submission scripts, which controlled the whole kind of submission of the MPMD system, and contained a fairly limited amount of cross-checking to make sure that what you were trying to submit made sense, you know. But those scripts were largely shell-based or a concoction of Perl scripts and that sort of thing. And so our current system is really based on what we've developed since the early 2010s, which is a similar setup from what we've seen before, although the GUI and the submission system and the configuration system has changed from the old Tickle-TK system to use a Rose and Silk based system. We have on the right hand side developed more comprehensive cross-checking pre and post submission checks, but they by no means cover all eventualities, and they, you know, if the user doesn't know quite a lot about what they're trying to do, then things can go wrong. So what does the user have to think about? Well, configuration, and that's not, you know, that's not just what's in the science components, but it's in terms of how you build, how you compile things. You have to worry about compiler versions and operating system versions, and pre-built versions of the coupler and other supporting software, and make sure that they're all compatible. And the systems that we've based things on have generally evolved from specific solutions, and thus we've tended to crowbar support for coupled systems into a system that was originally designed for use only, without without regard to the coupled system. And as I just mentioned, we also, in setting up something, you also have to consider your centrally managed, or what for us are centrally managed coupler installations. XIOS, which is it's kind of goes hand in hand with NEMO these days, and increasingly with other model components that we intend to use. And as I just said, we haven't redesigned that coupled model control system from scratch. We've tended to just adapt and sort of sledgehammer things in. It works, but data has to be duplicated, for instance, in multiple forms. So in a simple atmosphere-ocean model, the atmosphere must know what fields to couple. The ocean must know what fields to couple. The coupler must know what fields to couple. And there are lots of assumptions there that the user is going to get that right and going to know exactly how to specify that and change that. I should say that we have numerous flavors of coupled models, so there are lots of opportunities for these things to change and for the user to need to change them. There's quite a lot of flexibility expected of our coupled models. At the heart of this, we're using Oasis 3 MCT. At the heart of this is the NAM couple file, the coupler control file, and that's the thing which controls configuration dependent details as far as the coupling exchanges are concerned. This is just a snapshot of our current GUI, where within a suite definition, within model definition, these NAM couple files are carried around as static files in the configuration itself. And so this is just an example in the yellow highlighted box, the names of the coupling fields which are held within the NAM couple file. The component models need to know those. They need to get those right as well. But there's no automatic way to specify those in a single place. You have to enter them into the NAM couple file. You have to enter them into each of your components, or you have to somehow communicate to each of your components the names of those fields, etc. And things like other things in there, like about grids, about grid types, whether they're on UV grids, the remapping weights used, etc., etc. And so the user must assume quite a lot. These, I won't go through all of those in detail, but these are basically what a user needs to know about if they're intending to do anything more than just run a model that's been handed to them on a plate. They need to know about all the things on that chart. If they don't get all of those right, then it can lead to bad things. So what does it all mean? Well, it means that managing MPMD configurations is very difficult. That's not a shock to anybody, I don't suppose. Models may be prone to error. Users have to acquire a lot of incidental knowledge, and users are typically scientists. They're paid to do science, not to try and mess around with what might be regarded as the shortcomings of IT systems, and that can lead to, if they don't acquire the necessary knowledge and they're not prepared to spend time in regarding all these issues, then that can lead to wasted HPC and storage and time, etc. So my kind of dream is to try and improve this and at the same time catering for increasing flexibility. And that led me to believe that in the example just given, that the NAM couple file should be treated as the central common reference for all information regarding coupling, so that all components should interrogate that. But normal NAM couples don't contain all the necessary details for that. So we kind of concocted our own version of that. We added our own special extra data, which allows our unified model to just look at the NAM couple. It doesn't have to separately know anything about the coupling fields it's going to use or anything like that. It can interrogate that. And over the years, over recent years anyway, I've been sort of talking to Sophie about this and saying, "Oh, wouldn't this be a great idea?" kind of thing. And as if life isn't complicated enough, as mentioned by Dan yesterday, the Met Office is in the process of replacing the unified model with its next generation modelling system, which is ELFRIC, which uses a cube sphere mesh, completely new dynamics code. But importantly, ELFRIC requires brand new control mechanism, which is still subject to development, but so which I think might be an opportunity to move away from our sort of historical evolution to where we are, where we've retrofitted coupling functionality by sledgehammering it into existing systems, but to design the entire control system, the control driver from the top down, and treating ELFRIC and all the other components that we intend to use as just that, as just optional components. So that's just a sort of flow chart of where of what this might behave like, and the orange sections there, which the first sort of decision to be made is which components are you using, and then do you even need a coupler, and that that's something clearly that we can automate. And if the answer to that is no, then you can go and configure a standalone component. If it is yes, then you can go into a slightly more complicated setup where you're configuring a top-down driver and do all your coupled components from that. So stage 2 is sort of configuring the components. This is the job, as I see it, that the scientist, the user, is actually being paid to do. Not to sort of tinker with the code. So the user can go and set up the scientific configurations that they want to run. They can configure which fields need to be coupled, but we need to somehow tell them what viable couplings are available for any given configuration. I'm thinking that wouldn't it be great to just automate all that? Or to just say, well, you've selected this configuration, these are the couplings you can use. And so stage 3 is then to configure the coupler, which is the last thing to be done, as opposed to what we currently do, which is to create the NAM couple first. Which means to me generating the NAM couple on the fly at the end of the process. We have, from configuring components, all the information you need to know about coupling. We can then create the coupler control files on the fly and make it conform to whatever configuration we want to run. So I've completely changed my mind about how we should do that, how we should deal with the NAM couple files. Yeah, so this means that we have to build in smart functionality to generate the coupler control file. It has to be compatible with any supported coupler, or whatever we do needs to be compatible with any supported coupler and all the components we need. We need to worry about things like compatibility with compiler versions, with versions of XIOS, etc., versions of NetCDF, and that's extra responsibility for someone. But that responsibility already exists, as I sort of repeatedly indicated. It currently lies with the user. The good news is that we've started to do this for prototype models in our 3D atmosphere chemistry coupling, because those models need a huge level of flexibility. It's just impractical to predefine NAM couple files and all the other things that go with coupled models. The bad news: any change in requirements by coupler inputs requires software changes. We may need to support multiple formats to cover different couplers or different versions of the same coupler, or etc., etc. So there's a lot of extra work to enable this dream to happen. And what this is from the previous diagram. I've grayed out the things that I don't want the users to worry about. But the grayed out stuff still needs to be done, and it needs to, in my view, needs to be catered for by the automatic setup, by the automatic checking, generation, etc., etc. that I'm talking about, which is tough for the developer. But that's kind of the point. Somewhere has to deal with all these issues, and if we, as the software developers don't, then it falls to the user, and in fact it falls to multiple users who may or may not have all the relevant knowledge, and anyway are generally paid to do science, not worry about technicalities of the software. So my claim is the needs of the many outweigh the needs of the few. So yeah, I'd love to hear any stories or suggestions of whether this really is just a pipe dream, whether I've got a chance of pushing ahead with this, or whether there are other kind of solutions in existence that I should be thinking about trying to adopt. That's it. Thanks.
Yes.
All right.